What I'm about to teach you today is factoring by grouping. And just like that I taught you about the common factor, we have a polynomial that has degree 3. So we're going to factor by grouping. As you can see, they did parentheses. And then what they're going to do is they're going to factor a common factor. In this case, x squared is a common factor. And here we have -9 as a common factor. So they factor x squared. They factored x squared. They factored out -9. And then you see that they have a common factor of x plus 4. So they factored x plus 4. And this you can factor because it's a difference of squares. So you have x plus 3 and x minus 3. So for number 1, we have x to the third power minus 3x squared minus 4x plus 12. And you're going to factor by grouping. That's why you have parentheses around the first 2 and parentheses around the second 2. The common factor is x squared, and the common factor here is -4. And so what you're going to have is you're going to factor x minus 3. That's factored. And you're left with x squared minus 4. And so you have x minus 3. And you know that this is a difference of perfect squares. So this is going to be x plus 2, x minus 2. For number 2, we have x to the third power plus 6x squared minus x minus 6. So in the first parentheses, we're going to group the first 2 as they did. And then we're going to group the last 2. That's factored by grouping. Here we have x to the third, and here we have x to the second. So the greatest common factor is x squared. And we're left with x plus 6. Here we have -1 times x, and here we have -6 times 1. So we can factor -1. So we're left with x plus 6. And you notice they have x plus 6 in common. So you're going to have x plus 6, and you have x squared minus 1. X squared is perfect. 1 is perfect. So you have x plus 6 times x plus 1 times x minus 1. So I've factored this polynomial. So now another technique for factoring is the rule for the sum of two cubes. And here we have a to the third power plus b to the third power. And here is the formula. We have a plus b. That's in parentheses. And then we have the parentheses a squared minus ab plus b squared. Okay, so we have y to the third power plus 64. You know that 64 can be written as 4 to the third. So using the rule, we have a is 4, b is 4. So we have a squared is equal to y squared, and ab is equal to 4y, and b squared is equal to 16. So remember, we have a is y, b is 4. So what you're going to have here is you're going to have y plus 4, because we're following the rule. And then we're going to have y squared minus the product of the 2. So we have 4y plus 16. So in this problem, we have 8x cubed minus 125. So I'm going to rewrite this as 2x to the third power minus 5 to the third power. And then I'm just going to use that formula. Remember that this right here is a, and remember that this is b. So we're going to have, in this case, we have a minus b. So it's going to be 2x minus 5. And then we have a squared. So in this case, it's going to be 4x squared plus, and then we have AB, so we have AB, so it's 2x times 5, which gives us 10x plus remember that it will be b squared. So b squared, in this case, it's 5, so it's going to be 25. So that's how you factor a difference of two cubes. We followed the formula. A minus b times a squared plus ab plus b squared. So if we look at 5, we have 27x to the third plus 8. And you notice that we have 2x raised to the third, and we have 2 raised to the third. So this will be 3x plus 2, because I know it's going to be a plus b. And then we have a squared. In this case, it's going to be 9x squared plus, you're going to have to multiply 2 times 3x, which gives us 6x. That's going to be AB. And then the last one is going to be b squared. So in this case, it's going to be plus 4. So the factors will be 3x plus 2, and we have 9x squared plus 6x plus 4. This won't be a plus, just to make the correction. That's going to be a minus, and that's going to be a minus. The formula is a plus b times a squared minus ab plus b squared. And that's for a cubed plus b cubed. That's the formula.